there is a reason for titration, and one of the reasons is standardization of a solution. So what do we mean? It implies that with titration, we can standardize a solution. And what does it mean to standardize a solution? First, I want to define a standard solution. And a standard solution is a solution with a known concentration. So it's either you know the mass concentration or you know the molar concentration. But so far as you know the concentration of the solution, then it is a standard solution. So, for example, in standardization of a solution, we get to know the concentration of the solution by titration. So let's say A is a solution of an unknown standard. That is, we don't know the concentration. While B is a solution with a known concentration. When we titrate A with B using an indicator, we will be able to know at the end of the reaction, through our calculations, we'll be able to know from the volume of the acid used to calculate the concentration of the unknown solution. So one of the uses of titration is what? Standardization of a solution. So we are looking at that right now. So we have a question on the board. It says A is a solution of tetraoxosulfate acid. We are not told the concentration. While B is a solution containing 0.050 moles of anhydrous sodium triiosocarbonate 4 per dm cube. Now, remember what I taught you the last time. I told you that they will not tell you, oh, this is mass conc or this is molar conc. But remember the units. It says B is a solution containing 0.050 moles of anhydrous sodium triiosocarbonate 4 per dm cube. What does it tell you? Mole per dm cube. And what sort of concentration is this? Is it mass conc or molar conc? Tell me in the comment section. Alright, so, and after the titration between A and B, in the titration, 25 cm cube of B was used in the titration, and the average volume of acid used was 24.35 cm cubes. So the first question says, calculate the amount of sodium triiosocarbonate 4 in 25 cm cube of B used. So this is a very simple question because we know the formula for amount. So the formula for amount says molar concentration multiplied by what? The volume, but this volume must be in a particular unit, which is what? dm cubed. So here we have 25 cm cube of B was used in the titration, and according to our question, it says calculate the amount of sodium triiosocarbonate 4 in 25 cm cube of B used. Now let's look at our parameters. Molar concentration of B was given. So molar conc, this is amount of sodium triiosocarbonate 4. So molar conc of B as given is 0.050 moles per dm cubed. Remember, I explained that. It says this mole was in 1 dm cube. So this is actually the molar concentration, number of moles in 1 dm cube of solution. So then the volume must be in dm cube. So our volume, which must be in dm cubed, we are given 25 cm cubed. And and 1000 cm cube is equals to 1 dm cube. So if we want to change cm cube to dm cube, we divide by 1000. So in our calculation now, when we want to replace molar conc, our molar conc is 0.050. Our molar volume, our volume is since we are going to change 25 to dm, so we have 25 over 1000 or a dm cubed. So this is multiplied by 25 over 1000. So I hope you are following. This is our concentration in mole per dm cube, and this is our volume in dm cubed. We are given 25 cm cube. So we change cm cube to dm cube by dividing cm cube by 1000. So this is our volume in dm cube, and this is what? Okay, so when we divide, we have 0.050 mole per dm cube. Please note that this is not really necessary. I'm just putting it to emphasize the fact that from the units of the parameters you are given, 0.025 dm cube. So dm cube cancel dm cube. Our answer will be 1. So when you multiply the two, you have 0.00125 moles. Yeah, you have 0.00125 moles. Just press your own calculator. But the most important thing is you get what I'm saying, okay? In case there is a calculating error, get the question right. Use your own calculator. Press it. Okay, so this is